All right, you guys. So for this first one, we have that our good old friend Billy is what they call a keen walker, who keeps a record of his performance so that someone can do a math problem at some point. Anyways, the following table shows the time in minutes it takes for him to walk 1 kilometer up hills with different gradients, okay? The gradient of each hill is constant. So first things first, I'm sure some of you are already thinking, damn, I do not know what gradient is. Gradient is a synonym for what they call slope, okay? You can also, or you might have heard it as what they refer to rate of change, all right? Usually I hear gradient or slope, rate of change is a little bit more weird, so we're gonna stick with the first two, okay? Um, And if you put this into your formula booklet, if you look for gradient, here it is. As you can see, it is m. And so gradient or slope is the famous m. And the formula is y2 minus y1 over x2 minus x1. What does y2, y1, and x2 and x1 mean? It makes reference to a set of points. So x1, y1 or x2, y2. And so it's your first x with your first y or your second x with your second y. Okay, it's just sets of points. All right. And as you can see, the y's are on top and the x's are on the bottom. So you can think about it this way. Basically, if you take a line, okay, the slope or the gradient is going to be how much you move by x, which is, the difference between x2 and x1, right? This is my denominator. And also by how much it rises, right? So here's going to be your y1, here's going to be your y2. And so as you can see, this here is exactly x2 minus x1, and this here is exactly y2 minus y1, okay? This is also why in some of your schools, it may have been taught to you as rise over run. How much you rise divided by how much you run in your graph, okay? And so in this case, you actually have a slope that is positive, okay? If you have something that cuts, like downwards, it's going to be negative, okay? If you have something that cuts straight across, it's going to be a slope equal to 0 because you're rising 0, right? But you're running something. So 0 divided by anything is going to be 0. And you also have the case where it's what they call undefined, which is just a line, a vertical line. This is going to be undefined because you're going to have some rise divided by 0. And anything divided by 0 is always going to be, ladies and gentlemen, undefined. Okay? So vertical slopes, undefined. When they're flat, they're equal to 0. And yada, yada, yada. See? Anyways, that's a little bit of blah blah for us to discover what gradient is. Then they tell us that the gradient of each hill is constant. Now let's understand what constant means for a second. So constant means that it's constant. It means that it doesn't change. Okay? And so here, Billy, our good old friend Billy, he recorded this table, he sent it to his math teacher, and his math teacher did an IBAISL November paper. Okay. And so, thank you, Billy. Thank you. Point is, when it's a constant gradient and we're talking about a hill, that means that what Billy is doing is that he goes up a hill and he considers the gradient constant. Okay? That means that the gradient doesn't change. It means that the slope doesn't change. And so, in some cases, he has a slope of what he says is 10%. In other cases, he has a slope of what he says is 4%, which is, of course, a little bit lower. Okay? And so that is what Billy is doing. He's saying, yo, this is a hill. The hill looks like this. It's constant. Okay? That's going to be relevant for part C. For now, we don't really care about that, but the context is very important. Okay, so that is what's happening. This is what's going on. And here is my table. All right. So at a gradient of 0, he takes a little less than 7 minutes to finish. At a gradient of 4%, he takes a little less than 9 minutes to finish. Okay, etc., etc. So for part A, part I, it says to find the equation of the regression line of t on g. Now, I need you guys to do the following. The moment you read regression line, you're going to be thinking graphing calculator, okay? Maybe you don't remember well where, maybe you're not so sure how it works, but you know that you have to use your calculator, okay? And so a big part of AISL, to my liking, is just understanding how the heck your calculator works and all the stuff it can do, okay? And so let's understand first what a regression line even is. So let's say you have a scatter plot with these points, okay? Whatever, it's a little spread out, who cares? See? Point is, someone shows up to you and they tell you, okay, what's like the average here, right? And so what you would do is that you would just kind of like try to trace a line that goes like in the middle of all of them, okay? That is your intuition for a regression line, okay? It takes all your different points of data, it tries to find sort of like a mean, okay? Something that cuts through the middle of most of them. And sure, there's going to be a little bit of spread here, a little bit of spread there. But point is, it's a regression line that can help you, I don't know, predict or understand better your data, okay? And so how do you find this regression line with your graphing calculator? Okay, the moment you read regression line, you're going to be thinking calculator, okay? And I'm going to show you when and where and how it works. See? The second thing is that here it says of T on G. Now, I'm sure a lot of you are reading that and thinking, what the heck is T on G? And first, I'm going to give you like the general form, okay? So the general form is regression line of Y on X. So what that means is that you are trying to like see the values of Y depending on what you got for X. Okay, that is huge. I actually said it in such a beautiful way. You are getting the values of Y depending on X. So Y depends on X. So now you can even say that Y is dependent variable and X is independent variable. Independent variable. Okay. And so notice how in this general sort of form, Y is the first one, X is the second. And so if you remember that, well, this T is going to be your Y, this G is going to be your X. So that means that this is your X values, and these are going to be your Y values. And so depending on the gradient, how much time does it take to climb up that hill? Or to walk 1 kilometer up that hill, better said. Anyways, once you consider that, it's a little bit easier to, see what you have to do or whatever, all right? So regression line, you're going to pull up your calculator. You are calculating some sort of statistical thing. So you go to stat, you go to calc to remember better where it is. And then you say, there it is, line reg, regression line, line reg, whatever. It's the same thing. Okay, linear regression, regression line, yada, yada, tomato, tomato. So you press here and you see what it asks for. As you can see, it's got an X list, it's got a Y list, it's got a frequency list, and it's got a store reg EQ. Now, it's important to think about it this way so that you remember what you have to do. So you press calc, you reach line reg, and you see that it asks for lists. So now you gotta go back to stats, go to edit, and edit those lists. So you're gonna erase both, and now you're gonna put the according ones here. See? And so I said that X was gradient, I said that Y was time, so I'm gonna say that the X is gonna be L1 and the Y is gonna be L2. Okay? Technically you can flip it, but I suggest that L1 is always gonna be X. Okay, just do it the same way always. X is gonna be L1. So you clear your lists, you put everything in. So this L1 is gonna be by X, which is gradient. And this L2 is gonna be time, which is a very interesting concept created by mankind. I just find it so powerful. The concept of time. I think it's one of the stronger concepts we've ever created. It's very impressive. Anyways, back to math. So you can go to stat, you can go to calc, and now you can do line reg. See? Now make sure that your X list is L1, or the one you chose. See? So to put L1, You see that blue button here on top of 1? So you press the blue button, you press 1, kapow! X list L1, Y list L2, and here you have frequency list. Guys, do you have a frequency list? No. I feel like a lot of you stress out and feel like you have to plug something in always if the calculator has it. You don't have to always do it, okay? And that has to do with feeling familiar with your tools, feeling familiar with your graphing calculator, okay? The day of the test, you're going to walk in with few things, okay? You're going to walk in with a pen and pencil. You're going to walk in with 2 years of having learned the world of IB math in your wonderful school, and you're going to have 2 hours of sleep, okay? What else are you going to have? You're going to have your formal booklet, so make sure you know damn well what's in here, okay? Always study with it. And you're going to have your graphing calculator. Okay, so the graphing calculator, you gotta know how this thing works because it's a tool that you're gonna use the day of the test. So always use it, learn it well. Frequency list, if you don't have one, you don't plug it in. See, some people here like freak out. They think they have to put something, so they just put L1 and sorry, yeah, they put like L1 or L2 or whatever, and chaos ensues. Okay, you don't always have to put something. Forget about it. Okay. Yeah, so frequency list, you're going to leave it literally empty. And here you have store reg EQ. So let's remember that this linear regression function thing is going to give you literally a line. And so if you want to graph this line for some reason, you can actually press alpha trace and you can put into any one of these. See? Now what are these y1s, y2s, y etc's? It's in your y equals, okay? And so if you want to be a cool kid, you can put it in here, graph it, and look at it. Technically, you don't have to. I mean, for what we care about, you don't have to. If you want to be a cool kid, you can, but whatever. See? Yeah. And then you press calculate. So you press calculate, you get all of this stuff. See? Wabam. Now, I'm sure at least one of you out there, and this is for you, my guy, or girl, or whatever. I'm sure at least one of you is looking at this and saying, dude, I did not get an R value. Why is this guy on YouTube getting values for A and B and also R, and I'm only getting values for A and B? That happens because you didn't say wablam loud enough. Okay, you gotta say wablam. What you actually have to do is press mode, okay, scroll all the way down, and there's this thing called stat diagnostics. You're gonna have this guy always on. There's no reason to have it on off, because if you have it on off and you do the same thing that I just did, you're gonna find out that when you calculate and you say wablam, you don't get R. See? You don't get R, even though it's the same process. So make sure this thing in mode is always on. There's no reason to have it off. It's only gonna maybe confuse you a little. See? So make sure that is on. Press calculate. Here are my values. Okay? So that was a lot of blah blah, but I think it helped more than one person out there. See? Anyways, for part AI, let me just write it over here so that we're all on the same page. You have, for finding the equation, right? Here it is. You have y equals your A value, which is 0.55213x, plus your B, which is 6.3570, 6.3570, and there it is. Okay? Technically, if you want to do significant figures, you count, for significant figures, you would count from here, 1, 2, 3, skip the 0, okay? And this one, do you round it up or down? I mean, do you round it up or keep it the same? You keep it the same. So the first one, if you would like, you can leave it as 0.52x plus, count 1, 2, 3. Do you round it up or keep it the same? You round it up, so you can leave it as 6.36, okay? So with significant figures, if you really want to, and just to keep it all in the same color, it would be 0.522x plus 6.36. Now, I did put y and x here, right? Now, because of context, which is y, which one is x, we said earlier that y is t, that g is x. So I'm just going to replace that quickly. You're going to end up with t is y, my bad. So you're going to have t equals 0.522 G. All right. So just to follow through with the context, that's what it would be. For part A double I mean, that's part A, part A. For part A double I, we have to describe the correlation between T and G with reference to the value of R, the Pearson's product moment correlation coefficient. So this is probably the longest buzzword you're ever going to have to learn for any test. Okay, so the moment you read this, you have to think line reg. All right, now that's something we already did. And as you noticed in our results, you have an R value. Okay, but if they ever don't tell you the regression line and they tell you about Pearson's product moment correlation coefficient, you got to go into line reg. Okay, so this is another big buzzword. Don't be scared. You just got to do line reg. And it helps you find the correlation, right? And so what I explained earlier, where you drew like the line that goes in between all of them, what this is trying to find is the correlation between your data. Now, what is a strong correlation? What is a weak correlation? Usually, think about an R equals 1 as a strong correlation. Okay, actually, equals 1 is a perfect correlation. So perfect correlation is equal to 1. Okay, and so anything near that is going to be strong. Equal to 0 is trash. Okay, or just not perfect, or opposite of perfect, whatever that is. See? So anywhere near to 1, you would say that it's a very strong positive correlation. See, if it's negative, then you would start saying it's a negative correlation, stuff like that. Okay? Anyways, so for this one, our R value was, or is, 0.9939. 0.9939. If you count three significant figures, it's going to be 0.994. Now, as I said, this is very close to 1, so you can call this a very strong positive linear correlation. Okay? The bigger buzzwords you have to say is strong, positive correlation. Okay? I think with this, you would probably get full credit. All right? Strong positive correlation. With that, you're fine. And if you want to like make sure you get the right answer, like 100%, you would say strong positive correlation because R close to 1. Okay? Or whatever. See? As long as you point out that you got the R value, it'll be okay. Yeah. So that is part A, part double I. Then they tell us that on Sunday, Billy intends to walk up a hill with a gradient of 13%. And so we need to estimate the time it will take Billy to walk 1 kilometer up the hill. Now this is pretty standard, but you have to really be careful on what is X, what is Y, and substitute correctly. So basically, in other words, for part B, what we're getting handed to us is that our good old friend Billy has a gradient. He knows he's going to go up a hill with a gradient of 13%. How much does he take? And so if you really translate this a lot, you would say G equals 13. What is T? All right. And if you want to put this as a set of points, remember that G is your X. So it's going to be 13 comma Y. All right. So, well, and in this case, it would be 13 comma T because T is Y. And so if you go ahead and plug that in, it would look like this. 0.522 times your G, which is 13, plus 6.36 is going to equal T. So you put all of this into your calculator. 0.522 times 13 plus 6.36, you get a T value of 13.146. T equals 13.146. And give me a moment. 0.522. Wait, give me a moment. Something is wrong here. Okay. I think this is what's wrong. Apologies for anyone watching this. Your A value, I hope you saw it earlier, but the A value I wrote down is wrong. So it should have been 552 instead of 522. So my bad. If you saw it, nice. If you didn't, it's okay. We all make mistakes. No one's perfect. And I'm glad I'm another example of that. So, yeah. So here you would have to plug in 552 times 13. So that's going to change my answer a little bit. Good thing I have the answer key next to me just to double check and make sure you guys get the proper procedure. Okay, I messed up again. Look at that. Boom. All right, that makes more sense. So T is going to be just about 13.536. 13.536. Now, because this is in time, you can think about it as T being equal to 13.5. Well, because you count 1, 2, 3, round it up, or keep it the same, 13.5 minutes. All right? So that is for part B. And then they tell us that this morning, for some reason, Billy walked 1 kilometer up a hill and it took 22 minutes. And we need to explain why, and this is actually something that happens almost always in these regression line examples, is that you need to explain why it would be inappropriate to use the equation. So everything you did, it's not that it's wrong, but it's, okay, what is good, what is bad about this, all right? And I know some of you might be thinking that you never want to do math again in your lives, but I think it's always important to just have the mentality in general, like, okay, the way you're trying to explain a problem, the way you're trying to model something, whether it's math or not, okay, the way you're thinking about something in your life, what is something about the way you're approaching this issue that maybe is not ideal, that maybe has something that in some certain scenario could maybe not work out properly, okay? I think it's always important to keep this sort of self-criticism going around in your life. And I'm not just talking about your math models, okay? I'm just talking about how you face stuff in general. So sorry for getting boomer on ya, but I think it's important to, be open-minded and criticize always, even yourself. More importantly, yourself. Always with love. So, what would be inappropriate about a linear regression? Okay, that's really what it's asking. What is inappropriate about using a linear regression? So notice how in this case, we, for part B, okay, for part B, we plugged in, this is very important, we plugged in, what did we plug in? We plugged in 13% as gradient. So we plugged in G and got T, which is the same thing, you guys, as if me telling you that you plug in an X and you get a Y, which makes perfect sense, correct? For part C, what you would be doing is plugging in a T, because of 22 minutes, to get a G, which is the same as saying that you plug in a Y to get X. And so that is one thing that you can pretty much always use for these sort of exercises. You can always say that using a Y on X regression line, which is actually the current context, right? Using a Y on X regression line cannot always make a reliable prediction for Y. They are always, almost always, for making predictions. Oops, I said this the other way around. Using a Y and X regression line cannot always make a reliable prediction for X. They're always good for making predictions for Y, okay? And so you're kind of like using it the other way around, not what it's intended, right? So anytime you have a problem where they tell you that you're using a regression line and you're trying to find an X value, you say, nah, usually you want to try to find the Y value. The standard is that you plug in X, you get a Y. And so for part C, you're plugging in Y and getting an X. So you say, this guy on YouTube told me regression lines don't work that way, okay? And I'm not saying that it doesn't always work, but I am saying that you encounter problems, okay? So for regression lines, that is one way you can earn this point, okay? The other way you can earn this point is quite simply saying regression line is for time on gradient, not gradient on time, okay? Which is a very similar idea to what I just said. It's a little less general, but the idea is the same, okay? It was not the intended purpose of the regression line. That's why it's not going to work well, see? The other thing you can say is that this estimate is what they call an extrapolation. And so an extrapolation is something where you look at your correlation. Okay, let's say you have a bunch of points here, right? And you say that the correlation is like this, right? You can try to do an extrapolation to predict values that are over there, right? But the thing is, this regression line is very effective for these values, right? And if you go beyond that, you would be entering the extrapolation sort of area. And so, unless your regression line really considers all the different scenarios and stuff, when you extrapolate, it's likely to be wrong. Now, it depends on the context always, okay? But let's say that you have a very extreme sort of gradient. Let's say that, okay, Billy's dealing with gradients from 0 to 20. Let's say you try to extrapolate for a gradient of 100%, okay? It's literally a vertical wall. Like, time there would be like so much more, you know? It would not be like wise to extrapolate with a very, very high gradient. And so if you suddenly have a very, very high gradient, it's an extrapolation, it's likely to be wrong. And so notice how here you have values from 0 to 20, and here they're talking about 22 minutes. I know it's not that far off. I would personally just use it as extrapolation and it's fine, but you do get a point for saying it's an extrapolation. Okay, so anytime you extrapolate, you can say nah, careful. Okay, so I think the two general sort of arguments you can always use is this first one, okay, and this third one. All right, those usually show up. The other two are like more context wise, and the other two being this last one as well. So the last one that you can say is that you can say that there is no reason to assume this new hill has constant gradients. Ah, so now we go back to all the constant stuff we talked about earlier. So our dear old friend Billy, he has been going on gradients that have a he has been going on hills that have a constant gradient. And so maybe this new hill that he's going up, maybe it's not constant. Maybe it's a hill that goes something like this, right? And so that is definitely not constant. And you can say that there's no reason to assume that this new hill has a constant gradient. So the model you should be using is not this one. Okay, that's your argument. And that is 4 different ways to get this 1 point. So again, that was a lot of blah blah, but I think it's important. It's a very easy point, you guys. And even if you get part A wrong or part B wrong, or you don't even know how to start it, or you're running low on time and shit like that, notice how part C is a context problem. Okay, sometimes you have these context problems that give you like it's not that it's 3 points, but like you can do part C without B or A. So be on the lookout for those kind of exercises, especially if you're low on time and you need to claw some points. This one is a context problem, which you can answer, or a context question, I should say, which is something you can answer right away. All right, that was a lot of blah blah, but I'm sure for some of you it was super helpful. So that is number 1, and I hope it helped.